So I'll be presenting the Jupyter notebooks in the Collaboratory 2.0. This is mainly giving you an idea of what is there, what exists so far, and the different workflows that you can use to be efficient with these notebooks. And then later this afternoon there will be a hands-on workshop. So Jupyter notebooks were brought into the Collaboratory with the goal of documentation, interactive instruction, automation, and exploration. This is the task definition where it was introduced. So for each of these workflows, I'll be presenting a bit more later. First of all, I'll go through a bit of what JUPYTERHUB and Jupyter notebooks are. I'll present the integration that we have in the Collaboratory itself, give some suggested workflows for different types of tasks, and present a bit the hardware it's running on and the implementation status. So a quick word in advertisement for my session later on. So the next session is by my colleague Alan, who will be presenting building an app in the Collaboratory. And then I'll be presenting a hands-on workshop with these Jupyter notebooks. So it's beginner friendly. You don't necessarily need to know much, if any, Python, but preferably a bit. You can pair up too. It will be preferable to do it in small groups. And I'll show you how to use the drive, give you an introduction to the Jupyter notebooks themselves, show you how to access a protected resource with an OAuth token, and how to add a widget. So we'll be building a sort of mini dashboard. These workshops will be fairly short. They're 55 minutes each. So to try and speed things up a bit, if you can do some of these things ahead of time, that will be great. So visiting the Colab to make sure your account works, logging in, visiting any Colab in particular, and looking at the drive section. If you stay for the next workshop, you'll have done all of that with Alan anyways. So what are Jupyter notebooks? Jupyter notebooks allow you to tell a story. So they allow you to embed Python code in a descriptive narration. So you can write raw text or markdown, if you're familiar with it, which is a way to, in fairly simple text format, add some, for example, bold fonts, headers, and then you can embed bits of code. So what we see over here, we have the Jupyter notebook itself on the right, and people can go through it and interactively run it. So this part is just this. So the first part is just descriptive, and then you can execute the parts that are in the code blocks. So here, for example, in this notebook, we're reading some data from a GitHub repository. So it's someone who's been tracking how many notebooks are being used and have been published to GitHub. And we're getting the data from his repository, and then we're plotting it. So if you're doing some scientific experiment, it allows you to either for teaching or for documentation, show the users, give the users an explanation and then show them how to actually reuse your data or how to do the experiment yourself. So the typical workflow for running a Jupyter notebook, it would be that you would install Python on your own notebook, on your own laptop, that you would start it up. You would have to have installed quite a few libraries. It's not necessarily that simple. And so JUPYTERHUB itself is a platform that is a central deployment of these notebooks. So rather than installing anything on your computer, you can just come, log into the JUPYTERHUB, and you'll have everything installed for you in the container. So some scientific libraries, and integration with the drive also. So basically a cloud storage that allows you to share documents with others through the Collaboratory. It's almost as easy as in the good old days when you just visit some malicious web page in Internet Explorer and it would install everything for you, but a bit more friendly, we hope. So the JUPYTERHUB, Jupyter notebooks in the Collaboratory. So this is what it looks like. It's the newest Jupyter Lab interface. So if you've been using notebooks before it changed a bit, you can still use the old interface too, but this is by default what shows up. So what you'll see here is that you're already in a Drive folder. So you can see the list of collabs that you're a member of and that you have access to, or public collabs are ones that you're a member of. And if you navigate inside it, you'll see all the files, and they'll be directly on the file system. So you don't need to do any of that storage client get files and such as you had to do before. The authentication is integrated. So right now it's the authentication from the Collaboratory 2. So most of the services won't be compatible yet. We're still working on that. We also provide high-level support for Jupyter notebooks. So if you have questions, you're welcome to ask us. And we'll try and help you out. Yeah. And it's deployed on Kubernetes for those of you that it interests. So typical notebook use cases. As we've mentioned in the beginning from Plus, the notebooks are used for documentation. So for example, the Elephant Electrophysiology Toolkit has a notebook that shows you how to step through the library. It's also used for interactive instructions, so I'll be giving a demo later this afternoon. But it's also been used by the brain simulation platform for running the massive open online courses, the MOOCs. It can be used for automation. So for example, you can use it to launch a task on the HPCs using Unicore. And it can be used for exploration, where here you can have some data that you want to analyze to try and get ideas. So you can do visualization, you can do some data analysis in there too. There are also some live papers that have been published that linked to some Collaboratory Jupyter notebooks in the first Collaboratory, where people have published a paper and added some data sets and some code that will allow users to reproduce part of their experiment, which allows readers of the paper to actually understand much better and to possibly criticize or develop it further. So a typical workflow would look like the following. So you have a project and you want to create a notebook. So you want, for example, to do a presentation. So you'll create a collab, save the notebook in the collab's drive, add some data also in the collab's drive, and then you'll write some code in the notebook that will explore your data, perhaps do some graphs, some visualization, and finally you'll save some output and possibly the visualization, sort of the graph that you have done, and share it with others. So creating the collab. If you visit the Collaboratory wiki, so wiki.humanbrainproject.eu, and you're logged in, if you go to the collabs page, this is what you see. So you can create a collab by clicking on the big green button. In your new collab, you should see on the left in the menu, there's a link to the drive. If you go to the drive, yeah.
Yeah, sorry, I don't know if it's very predictive if I interrupt you with questions.
Maybe after?
Let's say
okay, or if it's particularly. Okay. Yeah. Okay. Yeah. So here you can see the path to the drive, and in the drive, try refreshing the page, by the way, if ever not. So you can navigate into the folder structure, and you'll have the data that's been saved to the drive. So it's a bit like Dropbox. The drive is a bit like Dropbox. It allows you to upload data and share it with others. And over here we have a notebook and some data that we'll use that we'd be using in the notebook. So if we skip back to the notebook view itself, the data that we saw previously in the drive is also available from code. And so there are different workflows than what we had previously that we'd like you to use. So basically anything that's in the drive will be available with the same path for all users. So if the user has access to your drive in a read-only way, this file that was uploaded as data or configuration will be available to everyone using this path. So if you write in your code open this file and use the contents, it will work even if they copy the notebook somewhere else and run it anywhere on their, in their container. So you don't need to do anything special. They don't need to download it. They don't need to copy it. So previously there were a lot of workflows from, for example, the brain simulation platform where they would have to clone a whole Collaboratory or lots of files and the notebook into your own personal Collaboratory so you'd be allowed to run it. We now have something that's a lot simpler where basically you can use the path relative to the drive and anyone can open that file and read it. So you just need to use paths that are relative to the user's home to access those files. And when you want to save the files, so if you have only read access to a Collaboratory, you won't be able to write to it in the notebook. But what you can do is you can either write it directly to your home, which is kind of scratch space, or you can write it to, in Drive you have My Libraries, so those are your kind of personal, it's your kind of personal space on the library. And you can write the output there and keep it for later. It will be synchronized immediately to the drive. You can see it from the drive interface also and share it with others if you want to. You can also create a collab for yourself, which you could then also share with others through the usual workflow. So you could save the output to a shared collab too. And in certain workflows, you'll want to actually have a collab that you share with many members that have edit rights. So if you're doing some exploration and you want many people to be collaborating, trying to make some changes, running them and looking at the outputs, you can also just have everything be in a read-write library, which, well, by making them editors of the collab, and everyone can collaborate in the same space. So there are, as I've mentioned, various workflows. So I've kind of put in tabular form what we expect and how we hope that you'll use them. How you will hope you use the drive and the notebooks. So if you're doing documentation, so you're documenting your own library, for example, we expect the input data to be fairly small. You have some small example set. It's a few kilobytes, maybe a megabyte. It's shared. Everyone uses the same data set. It's read-only. So you don't expect people to be able to modify it. It's just documentation. If there's output, we expect it to be volatile. They'll run the small example, but they don't need to save it. There's nothing particularly important there. So you can just save the output, so write it to the home. And the workload is relatively light, so you just run it in the notebook and it should work. The next workflow is exploration. So here what's a bit different is you have somewhat bigger data and you actually probably want to keep some of the output. So the data would be small to medium. It's not something that would be HPC sized. It's something that's shared, so you might be many people, well, you can be alone, you can be your own team, but maybe you also have other members you're sharing it with. It's read-write, so you'll be making changes to it, you'll be modifying it in place, or in the same area at least. So for that, you can use either your own library or a collab that you've given many people access to. So libraries are basically folders in the drive. The output should be persisted, so you want to write it back to that Collaboratory or in your personal drive. So you have workflows where you can create a folder with a timestamp, for example, if you have multiple runs. But everything is persisted. And the workload is light to a bit bigger, so you can see, but you're still running it on the actual, typically on the actual JUPYTERHUB deployment. Then you have a teaching workflow. So this is what, for example, for the MOOCs or for these workshops. So once again, the data size is small to medium. It's also shared, and it's read-only. So you're not actually modifying the data, and nobody else should be able to write to it. So you put the data in the drive for of the collab that you're sharing. The output should be persisted probably, so you might want the students to submit an essay, or not an essay, but submit their output or submit the results. Or sometimes it might not be necessarily persisted, but even for them to be able to review it. So you can either save it to the user's drive, or you can create specific collabs for each student that they would be submitting the data to, so that you can grade it. And once again, it's a light to medium workload. It happens in the on the Jupyter Notebook server itself. And finally, you have the automation workflows. So these are the ones with big data. They're the ones that will run some task on the HPC. And so the data is probably large. It should not go in the drive. It's not an HPC grade storage. And so you have to deal with that outside of the collab or outside of the notebook infrastructure. The output is also large and also should be dealt with online, so somewhere in a CSCS container, for example, but also not persisted to the drive. And the workload is heavy, so you should be using probably something like Unicore to pass it on to the HPC. Yeah, so that's kind of the 4 main workflows and ways to use the notebooks. Yeah. And so in terms of the hardware that we're running all of this on right now, so the preview environment which you have access to right now is running on a development version of OpenShift. It was set up by our team on top of CSCS's VM system. It's not that stable. It's connected to the production drive, so you can already start trying it out trying to convert some of your notebooks to use it from the Collaboratory one. There are 5 worker nodes. And there are lots of users starting to try out the Jupyter, the Kubernetes infrastructure, sorry. And so we've had some stability issues. Some teams have been causing some out-of-memory issues. And we should have improved the situation a bit where the whole cluster won't, or at least the node won't crash anymore. But we have to see. That's only been put in place this week. But soon we will be migrating it to the Kubernetes that CSCS has just released, actually now 2 weeks ago. It's somewhat beefier. It has 10 workers with 86 gigabytes of RAM each. So you should be able to run somewhat bigger workloads on it. It is shared by all Collaboratory, well, it will be shared by all Collaboratory managed Jupyter instance or Kubernetes tasks. So there are various other tasks like the image service that probably will be running on it. So it's still not an HPC, but you can run somewhat bigger workloads on it. The cluster isn't configured yet, however, and the hub deployment will need to be adjusted since it's a different flavor of Kubernetes. So hopefully when I get back, I can work on that and have it out by Christmas. I won't be working on Christmas itself, so don't break it. The drive itself is much less powerful, so it's basically hosted by a single VM. It's running C drive, or C file, which is a Dropbox-ish clone. It has a limit of 1 gigabit per second in terms of bandwidth, and that's shared by everyone who's using the drive. So if you're downloading files from the Collaboratory on the drive through the drive directly, or whether you're using a Jupyter notebook to read or write to it, so it will quickly become a bottleneck. And the backing storage right now is only 126 gigabytes. So it doesn't report that right if you look at DF. I have already crashed it once while trying to test big sample data on it. So please be careful right now. We will expand the drive a bit, but we're limited in how big the block storage allocation can be for the VMs. So the drive is a convenient cloud storage. It's available, it's mounted directly in your notebook. It makes the smaller workloads quite much easier to do than previously in the Collaboratory 1 Jupyter notebooks. But it's not a high performance storage system and it's shared by everyone, so try to be nice again. So availability, well, the preview environment is out. Try it out, come to the workshop in an hour and a half, an hour. And start also probably trying to migrate some of your notebooks from the first Collaboratory. That's what we're going towards, and it should be a lot easier to use. And some things aren't done yet, so we plan to integrate it better with the Collaboratory. Oops, did I? Sorry. Yeah, so I just added the OAuth tokens in the notebooks this weekend, so that's working now. And I'll be demoing it later. Unicore isn't related to that OIDC. It's related to our new OIDC system, so the clients for Unicore don't match, so you won't be able to use it for Unicore yet. But I've seen burnt around, and we should figure out the migration path for that. Documentation is still quite lacking. Possibly I'll be documenting some things with you guys this week, and I'll be continuing to document it in the following days. And the meager documentation that already is there is already somewhat out of date, so we'll have to work on that. And for the curious and motivated, some ideas: adding code snippets, integrating the code snippet library directly into so adding code snippets to the documentation, integrating those directly into the notebooks. Google's Colab has a great version of that. Integrating the neuroscience tools better. I think there are some people here this week we should talk to. And so if you have any other ideas too, just come and see me. If you have questions, I'll be around too. So in summary, the new Collaboratory's JUPYTERHUBs are more performant than what they used to be. We can control quota on them, which will also make it harder for people to break the whole platform. And they should be a lot easier to use with the Drive integration than the old storage clients. But the Drive is not an HPC component, so keep that in mind. And do you have any questions?